Hi guys, hope you guys are doing well. Welcome to our show. It's called Calculator Tricks with Kelum and Kokila. We are going to show you tricks from calculators to calculate stuff with matrices, standard deviations, integrations, derivations, all those stuff. We will be doing those things using a calculator, so you will be able to ease your mathematic homework and all, because most of the time when you do these kind of calculations using your hand, it takes a lot of time, but you will see when you use a calculator it's much easier. So for this tutorial we are going to use the calculator Casio FX991MS, but most of the calculators work the same way, so even if you don't have this one, most of the time you will be able to do your calculations using the same method. Okay, today we are going to teach you the way to get an inverse of a matrix. Before that I will teach you what a matrix is. I hope you guys are already aware about matrices. So a matrix is it's a storage where you can store numbers, like for example, if you store numbers like this, 3, 4, 5, 6, this is simply a matrix. This matrix is called it's a square matrix where the dimensions are 2 by 2. As you can see, there are 2 rows and 2 columns, so it's a 2 by 2 matrix. And there's a thing called, if we name this matrix as A, then there's a thing called an inverse of a matrix, which can be represented by A inverse, like this. So the basic idea of an inverse is when you multiply a matrix by its inverse, the output should be an identity matrix. Okay, what an identity matrix is, before that, to calculate an inverse of a matrix, the matrix should be a square matrix. Square matrix means it should be either 2 by 2, 3 by 3, 4 by 4, or something like that, which means the number of rows and the number of columns should be equal. So to calculate an inverse, definitely you have to have a square matrix. So if you have a square matrix of 2 by 2, such as this one, the identity matrix will be like this: 1, 0, 0, 1. This is the identity matrix of a 2 by 2 matrix. This is 2 by 2. And if we take a 3 by 3 matrix, the identity matrix will be 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the identity matrix of a 3 by 3 matrix. So as you can see, in an identity matrix, the diagonal should be always filled with ones. Here also, as you can see, the diagonal is filled with ones. The rest of the spaces are filled with zeros. If you take a 4 by 4 matrix, the identity matrix of it should be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. So this is the basic idea. The diagonal is 1, diagonal is filled with ones, and the rest filled with zeros. That's the basic idea of a diagonal matrix. So if we take this example, okay, no, we'll take another example. We'll take A as 4, 3, 3, 2. So as you can see, this is a 2 by 2 matrix, and the inverse of this matrix should be 1, 0, 0, 1. And when you multiply the matrix by its inverse, you should get this particular identity matrix, should be I. So I'll first, before calculating the inverse matrix using the calculator, it can be done manually, but I'm not going to do it manually. You can easily do it, but I don't think you can easily do it, but it's a process. If you calculate it manually, you will get a result of minus 2, 3, 3, minus 4. So this is the inverse matrix. this is the actual matrix. When you multiply this matrix by this this inverse matrix, which is also a matrix, you will get the identity matrix.